Okay, good afternoon, everyone. My name is Thorsten Lind. I work for the EGLV, or Emscher Genossenschaft Lippeverband, how you pronounce that correctly in German. Yeah, we are the largest wastewater treatment plant in Germany, and I will today talk about how we are preparing for the quaternary treatment. This is particularly challenging on this location, and how we use the CFD modeling from AM team to improve our initial planning and yeah, got to a way better result than what would have come out without the CFD modeling. So who are we? Where are we located? We are in the middle west of Germany, and we consist of two public wastewater management associations that are governed under one common structure. That's why there is this very long name, Emscher Genossenschaft Lippeverband. Emscher, the first part of the first word, is the river that passes through the blue part, and Lippe is the river's name that passed through the green part. We cover over 4,000 square kilometers of catchment area with a population of 3.5 million, so that's nearly 5% of Germany's population. It is the former coal and mining area, which is why there was initial founding of the wastewater association in the 19th century, because wastewater became a real problem there. It all went through the open water rivers, and it stayed this for a very long time. Just in the last 30 years, the EGLV managed to bring everything underground, and we now do have a network of 430 kilometer underground piping, and the rivers are now wastewater free. But that was not the case before. And in particular, we also set up 4 large-scale wastewater treatment plants. And the one we talk about today is the largest one. It's the one close to the city of Bottrop. It has a capacity of 1.3 PE, population equivalent, and is located right next to the river Emscher. So in a dry weather season, we, with our regular wastewater, do a substantial part of the water that then is discharged into the Emscher River, which is why we need to take care of the quality of the discharged water much more. And we now have a new regulation in the European Union saying that large-scale plants have to implement the quaternary treatment step until the year 2033. Its purpose is to remove the micropollutants by at least 80%. There is a directive for it named CARL. CARL is the abbreviation for Kommunale Abwasserrichtlinie, a very long German word. It basically means Urban Wastewater Directive. And this is what we need to fulfill, but we have some very specific site challenges and a preferred treatment version, which is we want to do the quaternary treatment with ozone and sand. There is other treatment versions that are more textbook, but we would like to do the ozone sand version. And our particular challenge is that the wastewater that arrives at the treatment plant in Bottrop has high loads of bromide. Bromide itself is not a problem, but if you treat it with ozone, it oxidizes into bromate, and bromate is highly carcinogenic, which is why the authorities are not very keen on this method. There's other methods where it's more well known that this problem does not occur, or you get rid of the problem with the bromate formation. Nonetheless, we really would like to do the ozone sand version, major reason is it is more environmental friendly than using the granulate active carbon. It needs less space than the other treatment versions, and we do have a particular problem with footprint or with space on site. And third, we want to be more independent of supply chains. So we discussed this a lot with authorities, and yeah, because of the high bromate loads, they said, okay, how can we cannot allow this without any proof that you can manage the directive with the 80% micropollutant removal, and that you can keep the bromide level at a very low level. The only threshold they have in mind is that for drinking water, which is a bit exaggerating given that we are talking about wastewater. But if we would reach the threshold of drinking water, they said, then of course we can also grant you the permit for ozone Z. So we thought we should test that first, because the large-scale quaternary treatment will cost something between 150 to 200 million. This is a very substantial money that will come from our members. And so the idea is we first do a pilot project that covers about 3% of the usual wastewater. And with this pilot project, we will test in parallel our preferred version, the ozone sand. We will also test ozone and the granulate active carbon. And we will test the third version, which is called ozone strong water, to see if the results hold up, and then make the decision on how we are doing the large scale. So when we were thinking about this pilot project, we were wondering about the size, the dimensions, the length, and it occurred to us regarding the depth of the water, we need to do it one-on-one with the large scale, but we probably can have some improvements on the reaction chambers for the ozone injection. And this is where the CFD modeling came in. So with the CFD modeling, we thought we could see how the flow in the pilot project will look like. And we were wondering if there is room for improvement on how we are doing the ozone injection. So as a public company, everything needs to go through a tender, or we need at least a few offers from service providers who can do that. And me and my colleagues, we interviewed quite some companies for this. And then we also came into contact with AM team and learned that they had done this in the past before. And actually in the initial interview already gave us almost the solution to our problem. So we chose AM team and we discussed with them our initial design. They then took this initial design, run it through their model, and showed us over and over again how we can improve this. Jessica will talk about this after me, so I will not go into detail, but to give you a summary, the reactor could be much shorter than we thought to. We were initially planning 8 to 10 chambers. We now know we can do it with 6. We will, to calm down the authorities, we will still build 8 chambers, but given the CFD modeling, we will be good with 6. There will be 4 diffusion parts. So initially we thought we would inject countercurrent the ozone in the very first chamber. So you have seen this picture in the slides of Peter before. This is not the real pilot plant. It's just here for illustration. So you see how the residuals are dissolved over time. And initially we thought we just inject in the very first chamber countercurrent to dissolve the ozone and get rid of it through all the remaining chambers. Now the solution is that we will have a flexible setup with 4 diffusers in the first 4 chambers. And the results, given the CFD modeling, will be that we reach the 80% of removal of the micropollutant removal, and we will stay way under the threshold of the bromate formation that is important to the authorities. And the third one is that we already have some idea what is the optimal amount of ozone we should use in the pilot project. So after the modeling was done, the results were implemented in our initial planning. It changed the cube of what we were planning. The cube is now in construction. I do not have other pictures in just the CAD pictures. And we will have the ozone sand and the ozone granulate active carbon in parallel, and we will also have the strong water next to it. It's going to be finished in terms of construction by the end of Q2. So we want to start at Q3 this year with a year-round testing. And then a year after, we're going to summarize the results, and we're going to present them to the authorities with the hope that they then will grant us our preferred version, ozone sand. And we will roll out this with other plants that we already have in operation. Yeah, this would be all. And I give back to Peter.